So this is a question paper for IGCSE. Its paper code is 0971/04. It's a theory paper, as you can see. So let's go to the first question. That is, element X can undergo the following physical changes. So we have this element X. You all can see we'll start from the solid. So it's going through the process 1, which is getting converted into liquid form. And then we have the further processes. So we have to identify in this question, what are these processes 1, 2, 3, 4? So you all know we are going from solid to liquid. So you all know we have ice. The particles are very close in the ice. Haven't you all seen an ice cube? Yeah, so it's solid. Okay. And when it forms water, the liquid water. So what is this process? Going from ice to water, this is melting. So our process 1 is going to be melting. Going to process 2. Now see, what is process 2? The arrow is coming from gaseous X to liquid X. So what is happening when gases form liquid? Have you all seen that we heat water and then there's a lid over it? And you all know the water gets evaporated here and the gas particles, all the water vapor sticks here. And then when we remove the lid, on that lid, we have these water droplets. So what has happened? The gaseous water vapor has converted into liquid form again. So what do we call this process as? Yes, this is condensing or condensation. This is condensing when the gas or water vapors is getting converted into liquid again. Okay, now the third process. What is the third process? Third process is going from liquid X to solid. So it's like the reverse of it. So, yep, this. Our water is getting converted into ice. So how do we do this? We put the water bottle in the freezer and it gets converted into cold water or ice. So that's freezing. So here our answer is freezing. And the fourth process is from liquid to gas. How do we convert liquid to gas? As we discussed here in the previous question, we were heating up the water and it got converted into water vapor. So what is the fourth process? What should be the fourth process? This is boiling or evaporation. So we're heating it, which means it's boiling, or it can be evaporation also. I hope this is clear. So these are the physical processes, physical changes: melting, condensing, freezing, boiling, or evaporation, wherein only the state of matter is changing and not the chemical composition. It will still be H2O, given the example is water. Now, a sub question under this is, one difference between boiling and evaporation is the rate at which the processes occur. State one other difference between boiling and evaporation. So, boiling and evaporation is the rate. The difference is the rate at which the process is taking place. How fast is the process taking place. Now, they're asking for one more difference. So, have you all heard the term boiling point? Yes, there is a thing called as boiling point. Now, what is boiling point? Boiling point is a specific temperature at which the boiling is taking place. Okay, but we haven't heard of anything such as evaporation point or something like that. So this is the difference, that boiling happens, or boiling, the process occurs at a specific temperature, whereas we don't have any evaporation temperature. It occurs over a range of temperatures. So the difference here would be boiling occurs at a specific temperature, whereas evaporation is over a range of temperature. Yes. The next question. Describe separation, arrangement, and motion of particles of element X in the solid state. Now, in the solid state, how can we separate the separation, or how can we separate the arrangement or particles in the solid state? We cannot really do that, but We can talk about a sponge. How can we separate? Like if I take a sponge, it's a solid, right? So if I want to arrange, I want to introduce motion into the particles, what will I do? I will simply touch them. So touching will separate the particles or vibrate them together. Then what is the arrangement in solids? The arrangement will be equal and regular, repetitive pattern which is regular. So the arrangement is regular. And do they perform any motion? The solid particles, they don't move, they do not locomote or they don't leave their place, but they do vibrate. So their motion is vibration. Clear? All right. Question C. Element X is a group 3 metal. It burns in air to form an oxide X2O3. So write a symbol equation for this reaction. So let us write element X, and it is burning in air. So air, you all know that it is O2, and this is a combustion reaction, by the way. So if anything burns in presence of oxygen, it is a combustion reaction, and it is forming, they have already given us the formula X2O3. So what we have to do is simply balance the equation now. So how do we do this? O2. So we have three oxygens on the right and 2 here. So we put a 3 here to make it equal. But when we put a 3 here, this is becoming 6 oxygens. To balance this, I'll put a 2 here, which makes it 6 oxygen. But now my X is 2 into 2 is 4. So I have to make it 4 here as well. So this is your balanced equation. So this was about question 1. We solved about 3 sub questions under this.